I'll be explaining to you about integral calculus. It is also called integration. Okay, I will be giving you just a highlight of this integral calculus. So for integral calculus, we represent by this. Okay, now between this symbol and dx, there is a function that we're going to put. Okay, we put a function which we have to integrate. Okay, there are two types of integral calculus. The first one is called the indefinite integral. The second type is called the definite integral. Okay, so for definite integral, we represent this way, like a to b. Okay, we have a range and dx, and between them a function is there. Okay, now there will be a function here. Okay, so this is called the lower limit, this is called the upper limit. Okay, so we shall see later on about this definite integral. First, let us go to indefinite integral. For indefinite integral, we don't have that limits, okay, or that range. Now for indefinite integral, let's see one formula. Okay, the formula remains the same for both indefinite and definite. So this is a formula, x to the power n, if the function is of this form. Okay, d of x equals to x to the power n plus 1 divided by n plus 1 plus c. Okay, provided this n is not equal to minus 1. Okay, if n is equal to minus 1, we will get a, we will get a different value or the final answer. Okay, this will not be the formula. Now based on this, let's try out one example. Okay, so x to the power 2, we have to integrate. Suppose we are integrating this one, then integral x to the power 2 d of x equals to, see, x, so x, here n is 2. Okay, here n is 2, so 2 plus 1 divided by 2 plus 1 equals to c. Yeah? And this one will be x to the power 3 divided by 3 plus c. So this is the answer. Okay, now I'll give you one problem. Okay, x to the power 3 and x to the power, okay, minus 2. You try out this two and let me know. Okay, so these are the two questions. Okay, now moving on to the next one. Okay, there is one more formula. It will be applicable for both indefinite as well as for definite integral. Okay, that is called the product. Okay, the product. So integration of uv dx is equal to, okay, uv d of x minus, okay, d by dx of u integral v d of x. Okay, so this is the formula for the product u into v. If a function is of the form u into v, then we shall apply this formula. Okay, for the problem solving and all, it is not needed right now, so I'll explain you later on. Okay, now we shall go to definite integral. Okay, for definite integral, as I've said, we have a limit or a range, okay, from a to b, 0 to infinity, or maybe anything else, okay, or 0 to 1, 1 to 2. Okay, between this symbol and dx there is a function. Okay, so as I've mentioned earlier, that the formula remains the same. Only thing is that we have this limit for definite integral, isn't it? So let's try out one of the problem, say like for x squared again. Okay, we integrate this one. So between the limits, say 0 to 1. Okay, so integrating from 0 to 1. Okay, suppose the limit is 0 to 1, or maybe you can take any other number also. So 0 to 1, x squared d of x. Now see, x is x, the formula is here, x to the power n d of x equals to x to the power n plus 1 by n plus 1, okay, plus c. This is for indefinite integral, but if it is for definite integral, I'll change it this way, okay. Let's see, it will be like this, okay, from a to b, okay. This is how the formula should be for definite integral. Now come in here, see, our n is 2, so 2 plus 1, okay, divided by 2 plus 1, 0 to 1. That c, okay, which was there in the indefinite integral, I have removed already because it is a definite integral, so we replace it by the limits or the ranges, okay. So we get this one, x to the power 3 divided by 3 to the power 0 to, okay, 0 to 1. Okay, this should be the square bracket, it should be a square bracket, okay. Now in the next step, see, what is how we do is, we shall subtract from upper limit minus lower limit, which means for the value of x, okay, I mean this variable x, we will substitute by 1, okay. So upper limit minus lower limit, okay. Our upper limit value is 1, so 1 cube by, this is not a variable, so it is a constant, so we keep it as it is, 3, okay. 3 will keep as it is, upper limit minus lower limit, okay. So lower limit is 0 cube divided by 3, okay. Now 1 cube is 1, so 1 by 3 minus anything 0 by 3 is 0 only, okay. And we get a final answer is 1 by 3. I hope you are clear with this one, okay. So let me try one more, okay, let me try one more and you solve it by yourself, okay. I'll give some problems. So this time let's make it, say, you can change this one also, maybe minus 1 to 1, okay. You can do it like that also, but just for simplification, let me use it 0 to 1 only. This time let's take it x cube, okay. So 0 to 1 again. Now integration of x cube is like this, x 3 plus 1, isn't it, x 3 plus 1 divided by 3 plus 1, okay, square bracket is there and the limit is from 0 to 1, okay. So x to the power 4 divided by 4, isn't it, so 0 to 1 is equal to upper limit minus lower limit, so 1 to the power 4 divided by 4 minus lower limit is 0, so power 4 divided by 4, okay. So we just have to substitute the variable by 1 and 0, okay. So 1 is first, then 0 comes second, again upper limit minus lower limit equals to, the final answer is 1 by 4 minus 0 equals to 1 by 4, okay. So that is how we solve. Let me give you 1-2 problems, okay. You integrate 4, okay, you integrate 4, integration from, say, like minus 1 to 1, okay, for x square dx, then integration of 0 to 2 for x dx, okay. You try to solve this too. So that's all for the integral calculus. There are few more integral calculus problems which are needed, so that one I'll explain you in the later part of the course, okay. So for now only this much. You try to solve the problems that I have given to you, and if you have any doubt you can ask me.